Just, whoa. Are you seeing the screen?
Perfect, yes. All good.
The presentation? Perfect. So I'm going to present actually CCTP, that is cross-chain transfer protocol from Circle. So here the presentation. So mainly like what's the CCTP? Actually, it's a protocol designed to move USDC across different chains. As we know, like blockchains actually are sealed ecosystems, so they cannot communicate, they cannot send messages between blockchains, neither they can send tokens. So actually, the proposal from CCTP, since USDC it's already like centralized for Circle, that it's a meter, was like to create this protocol in order to natively burn and mint USDC tokens from one chain to another. That actually reduces a lot of trust assumptions that we are doing when we use bridges between different blockchains. So, well, different blockchain networks. So that's actually why it's important, because increasing interoperability also like expands the use cases in between multiple blockchains. But the challenge is that blockchains as isolated environment are not easy. And well, CCTP is solving that limitation. So I commented about like the advantage about CCTP on bridges. But first of all, is what it's a bridge. So mainly bridge is just a system that is designed to connect the isolated blockchain systems. There is different types of bridges. The lock and mint bridge that actually just send a token to the bridge and it means you a bridge token, or a pool bridging that you have like the token from both networks and you just send and receive the native one in the other chain. That produces capital inefficiency and also trust and security risk, since, well, actually for many reasons, and usually most of the hacks nowadays are on bridges, because usually it's like the weak part to attack. So CCTP actually is permissionless, it's composable, and it's also like capital efficient, since it burns the USDC in the first network, and it means the USDC native in the receiver network. So the process actually of transferring CCTP, you burn on source chain, and when it's born, actually the smart contract from CCTP will generate an attestation. The attestation is mainly a proof that something has happened. And with that attestation, after on the receiver destination chain, we will be capable to prove that we have born that in the source chain and mint native USDC in the destination chain. Some use cases or applications, you could build cross-chain swaps, cross-chain deposits, or also realize cross-chain purchases. Also combine it with other technologies, as would be like account extraction. So actually the user doesn't need like gas in the destination network to pay for the transactions. That are like the chains that support CCTP. As you see, like there is in many, but it's not in all the L2s. And the API, it's public.
Celo is not here?
Is not here.
Okay.
No.
I was thinking.
But actually, no, it's not here. But I remember Rajmi, maybe that it's a little bit of context, but could be like other protocols building on top of CCTP that could make it possible to actually have it. Yes. But that is mainly where it's deployed right now. Mainly because like you need like you need to have USDC in that network, that is mainly most, but you also need like the CCTP contract, that is the one that when it receives the USDC, it burns the USDC, and at the same time it generates the attestation, so you can prove that you have burned that USDC and you can mint it in the destination chain. Well, it's a little bit slow because it has 10 requests per second. And also, like, depending on the chain, you will need to wait a few blockchain confirmations before minting. And now, like, I'm going to, like, I have built the demo, so we can walk through all together. I will show you also some documentation. Yes. So here, actually, some of you will have received this document. Actually, I think it's in the Luma, and it was also sent by email. The whole workshop and information, and also like all the before setup you need, as the faucets and the testnet tokens you need, since you need like testnet. I'm going to be doing the demo on Ethereum Sepolia and Base Sepolia, so you need like Ethereum Sepolia in both of them. And also you will need some USDC, but testnet USDC, so you are not wasting like real money. You're playing with testnet money. And actually the process to get USDC, testnet USDC, is a little bit long. Here is just some configuration for the wallet in case you don't have experience. Here it's all the data. And well, getting testnet USDC, getting USDC. I'm not going to go through this process. It's a little bit long. It's step by step. I have been very comprehensive because mainly what you are doing is going to the sample app of Circle, and there you emulate a bank transaction. That is actually how the USDC is created. So actually, I found it pretty fun. And then you go through all the steps in their app, register, configuration, etc., until you actually emit the USDC. So as you can see, it's pretty long, so you can take it easy later. But once it's done, like, you will receive the USDC. And in case that you are not seeing it in your wallet, you just have to import tokens. And here actually the USDC address in the testnet, networks in Base and in Ethereum Sepolia. So let's build actually like the cross transfer app. First of all, I'm going to show the demo. Where is the demo? It's built on top of a scaffold is. It's here.
Yes. So just for context, we are using Scaffold to help you just to build any app super fast. And yeah, we're gonna make a special environment setup if you are not ready on Sunday as well. So yeah.
Yes, mainly because also if you are new to Web3, actually it's what Lena was commenting that Celo doesn't have, because it's more like user-friendly, but you need to get used to it, to a lot of configuration when you are building the app, mainly to connect to the client, to set up the wallet. And actually, for example, with Scaffold is, I comment that in the documentation, we are not going to write any contract, so we don't need any solidity actually for this app. But what happens is that we are interacting actually with contracts, so we need all that Web3 setup that can take a lot of time. So if you use Scaffold, it's already done by default, and that saves a lot of time. I will show you later, like, all the code of all the functions I have written are in the documentation here. If you go, well, here it's used like from scratch, how you start like the scaffold is. Here it's also like the documentation. Here all the links are set up. So mainly, like, when you start the scaffold list with NPX, you can choose the project name. After, you will choose the framework for Solidity. That can be H.E.R, Foundry or not. I selected Foundry, so you have it as an example. But actually, in this case, we don't care. We are not going to write any contract. And once like it's created, you will have to log in. And in case that you did the GitHub, the Git clone, then you have to do also yarn install to get the packages, just as I remember. I walked a little bit through like scaffold is, and here how it looks actually when you have done nothing. Ooh. But in my demo, I already have like the different functions I've written. So let me demo very, very fast. And actually, is what I commented in the process in the PowerPoint. First, we have to approve the USDC. So actually here, what I'm doing, I don't know if you're seeing the MetaMask, but now I'm signing actually the transaction. when you have to approve the USDC that you are going to spend in the contract. So what you are you are approving actually is the CCTP contract. In this case, it's a polygon network. So here, like, we are going to approve the USDC to spend it to the contract. It's being pretty slow. So at the same time, here, successfully approved. After, we are going to burn the USDC, so we see the contract. And again, I'm going to have to sign another transaction. I don't know if you see the MetaMask.
No.
Okay, I just it's just asking me like to sign actually the transaction. So it says 5 USDC and it says where it's being sent. It's processing. So at the same time, I will, okay. And now actually I'm going to MetaMask. Probably you don't see it. I get the activity, I can get a screenshot. And can you?
Yes.
Nice. So I copy the ID here, and that is actually what I'm introducing to fetch the station. Now it's going to look horrible, okay, because I had the things actually to make it pretty. That's taking some time, but I can put it here. And at the same time, actually, I'm going to request, well, this is like the just the station. It's doing it. So actually now, as you can see, I was like in Sepolia, but now I'm going to change to base Sepolia. So I switch network. Now I'm in base Sepolia, as you can see here, and here actually is where I'm going to mint the USDC. It's going to ask me again, oh, here you have the station that I'm already minting. Now it's asking me again to sign the transaction for the mint. If it fails, maybe it's because like we did not wait enough time. But I did it before. So here you can see like all the steps we have been doing. I'm going to leave that minting it, and I'm going to change to this window. Can you check the text? Okay. So here, as you can see, is the scaffolding application. So I have created, I will post also in the bottom of the document that Solange shared. I will put the GitHub, but I want to clean it a little bit before sending. So here you have actually the function to approve the USDC. It's just a basic contract approval. That mainly you need like the AV of the contract. Here is the USDC contract for like the network and the amount you want to approve. Choose 1/6, like 6 decimals. It's pretty standard. After you have the board USDC. So to burn, what we are calling actually is the deposit for burn function from the CCTP contract, where we are just giving the destination domain that actually it's the number 6, because we are sending it to base, and you have like the list of the different networks and the number identification number, the min receiver. That it's used in our case is the same address, but could be another, and the burn token could be another also, because now we are doing IBM transfer, but it also has like Solana, for example, network, and in that case is not going to be the same address as the sender, and the burn token that it's also like the address. After the burn, actually, we fetch the attestation. To fetch the attestation, we just get the transaction ID. I was doing it manually as an input test, but we could also emit an event actually to fetch actually that transaction ID. And with the transaction ID, actually what we are calling is the circle. the circle attestation to actually prove that we have borne it. So what we need actually from that attestation, first of all, we need the message byte, that is the transaction information that we did when we were sending to the CCTP contract to be born. And we also need the attestation itself, because that is what we are going to use to mint the USDC. So here now, finally, in the mint USDC, we have the contract. Depending on the network that we are going to mint, is one contract for CCTP or another. I know I'm going very fast, but because of that, I did the documentation because it's a lot of stuff. So in base is this contract, but you also have link in the documentation all the information about the identification of the network for CCTP. You also have like the contracts for USDC, and you also have like the contracts for CCTP. Like all the information is linked there. So use a small detail, like especially when you are like connecting here with the mint, you are getting like the provider actually from the browser wallet, in this case MetaMask. So the problem is that the transaction that you attested was in Ethereum Sepolia, and now you want to mint it. I switch actually networks, and now I was in base Sepolia. So actually what happened is like here is going to get base Sepolia. It's fine because actually I want to send the mint transaction, but in what it is the fetch, actually the fetch attestation, actually I was not getting the network from my wallet. I was forcing it to get it actually from the Sepolia. Like I was using, here, sorry, from Sepolia, Ethereum Sepolia. Why? Because if here I will have used actually the browser, once I want to change, and I want to change actually to base Sepolia, and it's going to try to find the transaction in base Sepolia, the transaction is not going to exist in base Sepolia. That transaction was generated, an attestation was generated in Ethereum Sepolia. So because of that, here you have to remember to make that change when you are looking for the attestation. So finally, like you just mean, and actually what you need is it's a little bit more. What you need actually is a message batch and the attestation response that you are getting from fetch transaction. And after you just build a transaction to the mint USDC, that is actually the function I was showing you that actually calls the receive message from the CCTP contract, and then it will mint the USDC in the new network. For creating this app, I have the utils functions and its own also and its own components that they are calling them. So it's how it works. I have not uploaded the GitHub yet because I want to remove all actually the scaffold its components I'm not using, so you don't get confused with them. But you have all the code that works on the document. So if you want to try right ahead, you will be capable just like creating the files and the components inside the scaffolding. That will be more than enough and it should work. I don't know if you have questions. That has been pretty dense. I know it was going to be a lot of dense. So also like check like documentation. It's step by step. I try just to put all information there, trying to don't consider anything obvious. And don't know if anyone has questions.
Your GitHub will be super useful.
Yes.
Yes, really. Like already got everything ready. It's quite impressive for us.
Yes.
Oh, sorry, my eyes. Oh, I have an issue with my eyes.
Yes, and actually, are you seeing? I don't know what you are seeing. Oh, perfect. Oh, you are seeing. Okay, you are seeing here. Actually, what they did, for example, like documentation is pretty good.
We are on the code.
On the code. Okay, that's not good. And now?
Probably
In the code, yeah.
no, we are still in VS Code. I think it's VS Code. Yes.
Yeah, I close.
What we share.
Okay, yes. So let me show you also like the circle documentation because it's very, very useful. You have all the links in the documentation I have made. So for example, what I was actually commenting here, you have the CCTP, but CCTP works with USDC. So USDC, here you have the USDC on testnet network. You have like all the addresses of the token that you can check. After you have like also a quick transfer, you can check, it's very useful. You have the cross-chain protocol. So here you have the EVM. You have the contracts. Yes, here you have the EVM contracts for mainnet, but if you scroll down, you also have like the testnet. So Ethereum stipulates 0, Avalanche Fuji 1, Base, that is one that we were using, was 6. Because of that, I was putting 6 there. You also have Solana programs. Yeah. 515.
Someone asked a question between CCIP and CCTP, if it's the same.
No, it's not the same. CCIP, actually, it's a cross-chain. I'm missing the I protocol from a Chainlink. Okay. And actually, it's a cross-chain protocol, like for different messaging and different tokens. CCTP is actually specifically from USDC and Circle. And actually, it works different because actually what allows you actually is that you are not using a bridge at all. What you are doing is that you use your USDC is bored in your network. So if you are in, I don't know, if you are like in Sepolia, here, actually that USDC is going to get born, so it gets destroyed in Sepolia. But because CCTP has the contracts and the authority to mint actually native USDC in another network, with the proof that it's the attestation of that born or destruction of that USDC, it's going to allow you to mint, to create native USDC in the destination network. So for example, Base. So actually what allows is just to born a native USDC from network to network. Apart from the gas fees of the chains, actually has no fee at all. And it's not a bridge itself. CCAP, I don't have the details of it, but is not the same. Yes.
The bounty on the chat related to Circle. So like Solon said yesterday, you can't use the CCIP bounty and Circle CCTP in the same time because it's not the same thing. So yeah, just to a friendly reminder.
Yes. And also as a clarification, no, sorry. Maybe it was that one. Nothing. Because I used here you have, by the way, just to comment, you have another sample app. It's already set up that you can test. It's prettier than mine, but actually, just going through, it got a little bit confusing because it's very well done. So actually, like, it's not so isolated as, okay, here you approve, here you born, here you attest, and here you mint again. Because of that, I decided to show like how actually CCTP works to build example how I did it. Here actually it's the same. It's probably kind of a scaffold. It's just git clone and yarn install, the same as actually scaffold is. And you can also test it. You will need to go also for the preparation, get like testnet tokens, etc., that you have in the documentation. And I did not found that pretty easy to go through. So now you have it there. And also check the documentations. Most of the information is there. I don't know if there is any question.
Probably
If
just one. If you can present yourself, especially as a hacker.
Yes. Okay, yes. I'm Raquel. Actually, I'm from Barcelona. Actually, my background is not, I'm not a developer. My background it's in electrical engineering, still technical background, but it's not the same.
Oh, Raquel will come back. Oops. No worries. I think
No problem.
yes.
I was also logged in from the phone.
Nice.
to read the comments. Solen knows me. I'm a little bit everywhere. Yeah. Okay, my background is not computer science. Actually, I'm an electrical engineer, so I myself I learned like code as many as you, like boot camps and also like workshops and a lot participating in hackathons. I really recommend it. Actually, I feel like in hackathons you learn a lot because you actually have to build something in a team, and you can learn from the teammates, but also like you have the mentors. So it's a little bit how I did it. I learned to code. I did a few bootcamps, and actually I started doing hackathons. And in this case, I have been its global finalist twice, and just recommend to participate. I always say the same, like there is many reasons why to do a hackathon as a portfolio, learn, make friends, actually. I think all the things open you doors, and it has been very, very helpful for me.
Thank you. It's really inspiring for everyone. Nice. So thank you very much for your workshop. I know you spend some time to make something super clear for all of us. And it's gonna be super useful to be ready for H Global and to make a really clean implementation. And yeah, really grateful for that. Yeah, thank you, Raquel. So I will upload the recording session in a couple of minutes on YouTube and send you an email. So yeah, don't hesitate if you have any question. Raquel, probably if you want to put your Telegram on the chat, someone want to just connect or send you a message related to the workshop. Raquel is like a pearl in the ecosystem, so don't hesitate to reach. Yes. Thank you everyone. And yeah, see you tomorrow for the next station. So it will be with MetaMask and Mina protocol. So yeah, let's go. Thank you everyone. Bye bye. Tschüss.